Hello everybody, we're back again with another installment of Tater Tot Academy, and today we're going to be dealing with multiplying and dividing radical numbers. This is just like factoring anything else. We just got that funky little square root sign in there. One of the biggest things we're looking for when we are factoring, like in our first one, we're going to be factoring, and then we'll be multiplying and dividing. But first we need to learn how to factor the radical numbers. The biggest thing we're looking for is either a pair of numbers that match or a perfect square. We can do this either way. So let's take a look at the square root of 180. So if I'm searching and I'm looking at 180, I can find that a perfect square that easily divides into 180 would be 9. So this would be the square root of 9 times 20. Okay. Well, 20 is not a perfect square, and I'm going to put a square around the 9. I'm going to put a square on the 9 to just signify to me that, hey, you found yourself a perfect square. So we'll continue with that 20. I'm searching for a perfect square with 20, and I will have a 4. 4 times 5 is 20. If I have a prime number, I'm going to put a circle around it to tell me I'm done with a prime. In this one case, just in case I didn't notice, I'm going to pretend I didn't notice that 4 was a perfect square. We know it is. 2 times 2 is 4, but I'm going to pretend that I didn't notice that. So I brought that down to a 2 and a 2. Well, I'm going to go ahead and put, I'm going to put a circle around my 2 and a circle around my 2 just to show me that I've found 2 more prime numbers. Next thing I'm going to do is I'm going to look at the square root of this whole thing. So I'm going to write another square root symbol. And I will take out a perfect square. So 9 is a perfect square. I will take the square root of 9 out, and I'll put a 3 outside of my square root symbol. Next, I have a pair. I have a 2 and a 2. So I'll cross out the pair, and I'll pull one of the 2 out of the pair. Because basically what that is saying is 2 times 2 inside of the square root symbol. And 2 times 2 I would see would be 4. I'm taking out the square root of 4, which is 2. Now I look and see what is left. The only thing that is left that is a 5. 5 is the only number remaining. So I'll go ahead and do the math outside. And outside it says 2 times 3. So that'll be 6. And I'll do the math inside. But the only thing that was left inside was a 5. So my grand total of this, the square root of 180 factors down to 6 square roots of 5. Let's go ahead and try it to the next level now. Now we're going to multiply these bad boys. So it says that I have the square root of 6 times the square root of 3. So I'll put a square root symbol, and I'm going to combine. If it's inside the square root, I can combine it. And if it's outside the square root symbols, I can combine it. So here I have the square root of 6 times the square root of 3. So inside I'll put 6 times 3, which will be the square root of 3 times 2, because 6 comes down to 3 times 2, and times 3 for the 3. If you notice, I said I'm going to put circles around anything that is prime. And I didn't have anything that was a perfect square. So in this next step, I'm going to take out any pairs that I have then. And I have a pair of 3s. So I'll take that out, and I'll take the 3 outside, and whatever is left inside. And the only thing left inside is a 2. So my grand total on this answer, the square root of 6 times the square root of 3, turns out to be 3 square roots of 2. Let's continue to kick it up a notch. Now I have numbers outside the square root symbol and inside. One thing we want to think about, square root symbols in this situation, the radical numbers, are acting basically like a variable. So it says 2 square roots of 5. I can pretend that's 2a. And 3 square roots of 10, well, the square root of 5 is not the same as the square root of 10. So I couldn't call the 10 an a. I'd have to call that a b. So I could say 3b. And it'd be no different than multiplying 2a times 3b. But now we're dealing with square root symbols. When I multiply variables, I can multiply the variables together, but that doesn't do anything to my number. So with that said, let's go ahead and look at this. If I look at what's outside my square roots, I have a 2 times a 3. If I look at what's inside, I have a 5 times a 10. And I can see that 10 will be 5 times 2. My next step, let me go ahead and see if I have any matches. Well, if you look inside, I have a 5 times a 5 times a 2. So I can take a 5 out of here. When I take the 5 out, I will put the 5 outside with everything else to be multiplied. So now my final step here, all I have to do is combine whatever I have. If I look outside of the square root symbol, I have a 5 times a 2, which is 10, times a 3, which would be 30. And then I'm going to look at what's left inside the square root symbol, and the only thing left is this good old 2 right here. So my grand total of 2 square roots of 5 times 3 square roots of 10 is 30 square roots of 2. Next, I have 2 over the square root of 2. Well, one of my big rules is I cannot have a negative number in my denominator, and I cannot have a radical number in my denominator. So this square root of 2 that I have on the bottom, I've got to get rid of it. I have to make it a whole number. Well, one thing that we know is that we can always multiply anything by the number 1. Well, here's a little trick for you. The square root of 2 over the square root of 2 is actually equal to 1. Because anything over itself is 1. Well, what benefit does that give me? Well, let's see. That will give me 2 square roots of 2. When I multiply the 2 times the square root of 2, I have 2 square roots of 2. And when I multiply at the bottom, I have the square root of 2 times the square root of 2. Anytime I have the square root symbol by itself, it will end up that number. But let's see why. Because the square root of 2 times the square root of 2, as we did before, would be the square root of 4. Well, we should all know that the square root of 4 is actually 2. So many times I'd have the square root of 2 times the square root of 2, the same number is multiplied, it is actually that number. So the square root of 2 times the square root of 2 is 2. Just like if I had the square root of 5 times the square root of 5, that would be 5. So I'll go ahead and rewrite this. Now I have 2 square roots of 2 all over the number 2. Whenever I'm dealing with fractions, I can always simplify, as long as it goes into everything. And if you notice, a 2 goes into a 2. So that'll give me a 1 and a 1. Well, I never put anything over 1, so the grand total of this is just the square root of 2. And there, I'm done. So it gets a little tricky. We can go back and check this out, but 2 divided by the square root of 2. I couldn't have a square root symbol on the bottom, so I multiplied it by 1. And I can pretend that the square root of 2 over the square root of 2 is 1. That was just so that I could multiply the square root of 2 by the square root of 2 on the bottom to give me a total of 2. Then I just reduced, and I'm done. Okay, on my next one, I have the square root of 3 over the square root of 6. Well, listening to what I did last time, we can imagine that I can multiply by 1. Well, the square root of 6 over the square root of 6 is equal to 1, because anything over itself is 1, like we said before. Well, let's go ahead and write. We're going to have a lot now. We have 3 times 6 here. And then I'm going to have the square root of 6 times the square root of 6. And as I told you last time, anything, when it's the square root number by its same square root number, it is itself. So the square root of 6 times the square root of 6 is 6. Well, let's go ahead and look at this now. I have the square root of 3 times 3 times 2 all over 6. Well, I have the matches, because 3 and 2 are all prime. 3 and 3 are a pair, so I can go ahead and pull one out, and I'll end up with 3 square roots of 2 over 6. Well, as we've been talking already, you can reduce fractions, so I have a 3 and a 6, which becomes a 1 and a 2. So the grand total of this one is the square root of 2 over 2. Okay. We'll continue to kick this up a notch, and I have 2 more. Now we get into something a little more difficult. As we've dealt with multiplying binomials, one of the rules of multiplying binomials that we have learned is the difference of squares. And we use the difference of squares to eliminate middle terms. In this situation, if I use a difference of square, I will not have a square root symbol anymore. Where if I use a sum of squares, I would. So let me just explain this again. So a difference of squares would be, I'm going to use the opposite of 3 minus the square root of 5 and go 3 plus the square root of 5. And as we've learned already, anything over itself is equal to 1. So I can go 3 plus the square root of 5 over 3 plus the square root of 5, because that is equal to 1. I'm going to use the distributive property on the top to do my multiplication. And 2 times 3 is 6. Then I have to go 2 times the positive square root of 5. That would be positive 2 square roots of 5. I'm going to look at my denominator now. In difference of squares, I only have to multiply the first terms and the last terms. That's just a rule of this. I don't have to do the middle terms because I know they're going to be eliminated. So all I have to go is 3 times 3 is 9. And negative square root of 5 times the positive square root of 5 is negative 5. Now I just plug and chug, go ahead and get some of this work done here. And I see that I have 6 plus 2 square roots of 5 all over 9 minus 5 is 4. As we said with reducing fractions, I can only reduce if it can go by everything. And remember, the square root symbols are not part of this. That is just a variable. In 4, I'm looking for something that is divisible into all 3 numbers of 6, 2, and 4. And I notice, hey, 2 goes into every one of those numbers. So the 4 can become a 2, the 6 can become a 3, and the 2 can become a 1. So if I rewrite this one last time for my final answer of 3 plus the square root of 5 all over 2. Okay, we have one last one just like it. It's our final one that we're going to do today, and we see we got radical numbers on the top and the bottom. As we learned in the last one, if I want to eliminate the square root symbols on the bottom when I'm dealing with a binomial, I'm going to use the difference of squares. So as we said, that is the exact same set of numbers just with a different sign. So it's square root of 6 and a positive 4 and a square root of 6 and a positive 4. Once again, we have to utilize, boom, we got to utilize our distributive property, and we go the square root of 3 times 6, and then we go positive 4 square roots of 3 all over. I'll go the square root of 6 times the square root of 6, which is 6, and I'll go negative 4 times positive 4, which is negative 16. Okay, let's go ahead and on our next step, and let's put these things together. And I've got the square root of 3 times the square root of 6. Well, hopefully I can see that in 6 I have a 3 and a 2. So I have 3 square roots of 2. And that would be plus 4 square roots of 3 all over negative 10. Wow, times negative 10. Well, I know I can't have a negative sign on the bottom. So I've got to transfer that. How am I going to do that? I'm going to multiply by negative 1 over negative 1. Because anything over itself is actually equal to 1. So when I do this, that is a distributive property here. So I have a negative 1 that is going to go times 3 square roots of 2. So now I have negative 3 square roots of 2. And then I have negative 1 times a positive 4 square roots of 3, which is negative 4 square roots of 3. All over negative 1 times negative 10, which is a positive 10. Now I look in, is there a number that 3, 4, and 10 that can be divisible by all 3? And the answer is no. So then I am done at that phase right there. My final answer is negative 3 square roots of 2 minus 4 square roots of 3 all over 10. Thank you for tuning in with another installment of Tater Tot Academy today. I hope you've figured out a little bit about these radical numbers. If there's anything you need, just go back, double check, look them over again, replay the different scenarios, and see if we can get those figured out. Thank you so much, and have a great day.